Dear students, this is Iqlaq sir. So I am back with one of the important problems in electrostatics, and that is equilibrium of 2 point charges. Okay, now see what the problem is. There are two charged particles. This is one charged particle carrying a charge of plus q. This is another charged particle carrying a charge of plus q. Both these particles are hanging with the help of two strings. All right. Now, since these two particles they are positively charged, they are like charges, hence obviously they will repel. They will repel by a force which is F, which is electrostatic in nature. So this is that force which is equal to F, given by the Coulomb's law. All right. So they will repel each other, and because of the force of repulsion, they will move away from each other, isn't it? They'll move away from each other. Okay. Now in this question, what you are supposed to calculate is, number one, you had to calculate what is the angle that the string makes with the vertical. So that means that you had to calculate this theta, number one. Number second is that you will have to calculate the tension in the string. All right, a very important question in electrostatics. So let's try to solve this question. Okay, the first and foremost you will do is that you will try to identify how many forces are there on one particle. So this particle is there. Now on this particle, there are how many forces are there on this particle? There are three forces on this particle. Force number one will be electrostatic force, this F. Force number second is tension in the string. And force number third will be weight of this particle in the vertically downward direction, which will be equal to M multiplied by G. All right, isn't it? Now next what I am going to do is that I will try to resolve this T into the rectangular components. I'll try to resolve this T into the two rectangular components. So obviously it will have two components. So let's try to resolve that. This component will be in the vertically upward direction, and another component will be horizontal component like this. All right. Okay. Now can you tell me, if this angle is theta, what about this angle? This also equal theta, isn't it? Simply because they are alternate angles. Okay. Now I will resolve this T in the rectangular component. So that means this component will be T cos theta, and this component will be T sin theta. Done. Okay. Now since this particle is in equilibrium implies that the net force on this particle is equal to 0, which means that this F should be equal to T sin theta, and this mg should be equal to what? It should be equal to T cos theta. Okay, so that means we have a couple of equations here. The equation number first will be like this, that this T sin theta equals to F, which is electrostatic force. And the equation number second will be T cos theta equals to M multiplied by G. So these are two equations for us, equation first and equation number second. Now what I am in search of is theta. So for that, to calculate theta, what I will try to do is that I will divide these two equations. That's equation number first divided by equation number second. When I will divide these two equations, I will get rid of this tension. Okay, just divide these two equations, this divided by this and this divided by this. Okay, this t and t will disappear. Sin theta by cos theta comes out to be tan theta equals to, this is here F divided by M into G, which means that this theta is finally equal to tan inverse of all this, tan inverse of F by mg. Okay, and why this F is equal to what? It's equal to electrostatic constant K. Q into Q is Q square divided by R square, given by Coulomb's law. Okay, so why the value of this F is equal to this, and it is given by the Coulomb's law. So we had this very important result. We have calculated what is the angle that the string makes with the vertical, number one. Number second is that I'm in search of this T. I'm in search of this tension in the string. Okay, let me again make this free body diagram. So there are three different forces on this particle. One force is towards right, that is equal to F, towards left F. In the vertically downward direction, there is a force which is equal to M multiplied by G. And at an angle, there's another force like this, which we call as tension in the string. All right. Now, can you tell me what's the angle between this F and mg? That's obviously 90. When the angle is 90, that means the resultant of this F and mg will lie somewhere here, isn't it? And that resultant will be equal to square root of this F square plus mg square. F square plus mg square. Okay. Now, since this particle is in equilibrium, means that the net force is equal to 0. That means this tension T should be equal to this square root of F square plus mg square. Okay. So that's what I'm writing here, is that the tension string comes out to be what? It comes out to be square root of F square plus mg whole square. That's it. So we have calculated both the angle which the string makes with the vertical, and we have calculated the tension in the string. All right. See you next time with one more important problem in electrostatics.